Question number 8 deals with the first part is half-life, second is the radioactivity or activity, and the third is what are the units of radioactivity. What is half-life? Same question, previous part. Original number n naught. On y-axis you have a number, along x-axis you have time. In the previous question, question number 7, we have proved that this number decreases exponentially. It will take some time. If n naught is 100, say, it will take some time for the population to reduce from 100 to 50. Half of this value. Half of this value is how much? N naught by 2. And this time is written as T half. What is half-life? Time during which the population reduces to half of original, 50% of original value. And once we define activity, then the activity also, the half-life will be defined in the same format. The time during which activity reduces to half of original, 50% of original. So what is half-life? Time during which number of nuclei or radioactivity reduces to half of original. What was the formula? Number at any time n is equal to n naught e power minus lambda t. At this particular point, time period t is equal to what? T is equal to e half. Number n is equal to what? N naught by 2. So n is equal to what? N naught by 2. This is n naught e power minus lambda t half. So this n naught is cancelled. What you get is 1 by 2 is equal to 1 by e power lambda t half. 2 minutes to write. How you solve it further? Yes, e power lambda t half is equal to 2. Yes, taking log on both sides to the base e. So it is log of e power lambda t half to the base e is equal to what? Log of 2 to the base e. If it is log of e power x is equal to what? Yes, power times x times log of e to the base e. Log of e to the base e is what? 1. So you can shift this power lambda t half log of e to the base e is equal to what? Log of 2 to the base e. This value is equal to what? Log of e to the base e, 1. So this value is 1. So t half is equal to what? Yes, log of 2 by lambda. Log of 2 to the base e is 0.693. So half-life is equal to 0.693 divided by lambda, where lambda is what? Lambda is decay constant. 2 minutes to complete. Activity, again it's same parameter, death activity. Radioactivity, or in the given model, village model, it is death activity is proportional to population. This is the first line written today. Means what? Minus dn by dt proportional to population n, constant proportionality lambda tk. This parameter, death activity, death rate, number of persons dying per day, number of nuclei dying per day, is written as R. Radioactivity is equal to lambda into n. N is equal to what? Yes, n is equal to n naught e power minus lambda t. N is equal to n naught e power minus lambda t is equal to, what is this thing equal to? Say death activity, radioactivity, activity is proportional to population. Lambda into n gives you activity. Lambda into n naught gives you what? Yes, lambda into n naught. Yes, anyone? Lambda into n gives you activity at any time. Lambda into n naught gives you activity at t is equal to 0, original value, R naught. And if this is R naught, lambda into n naught is written as R naught. It is R naught e power minus lambda t. Means what? Activity also decays exponentially. When the population is more, activity is more, death activity is more. When the population is less, activity is also less. The first line is activity is proportional to population. Population decreases exponentially. Activity also decreases exponentially. What's the graph? R along y-axis, T along x-axis. Activity, how activity will decrease? Yes, R is equal to R naught power, R naught into E power minus lambda t. And here also you can define time, half-life. Same. Time during which the activity reduces to half of original. That is what percentage? This is 100%, 50%. This is how you can write. In the next half-life, yes, in one half-life the number reduces to, yes, 100% reduces to 50%. In the next one half-life, this is one half-life, this is another one half-life. It will be half of this value. Half of 50 is what? 25. Next half-life, yes. In next half-life, this number will reduce to half of this value, 12.5%. Time with you is 3 minutes to write. 3 minutes to complete. R naught is initial activity. R is what? Activity at any time t. So what is conclusion of 7 and 8? The number decreases exponentially, n is equal to n naught e power minus lambda t. Activity or death activity is proportional to what number? So it also decreases exponentially. Formula for this is what? R is equal to R naught e power minus lambda t. Refer to notes C part. Units of activity. Units of radioactivity or activity alone. Units of activity or radioactivity. Yes. First one is what? Curie. 1 Curie. Then 1 becquerel. Then 1 Rutherford. RD. Values. Yes. Question number 1, competition. Which one is SI unit? Becquerel. 1 decay per second. Agreed? 1 becquerel is 1 decay per second. This is SI unit. What about Curie? Yes. 3.7 times per 10 decays per second. What about the Rutherford? 10 is per 6, 1 million. Rutherford is 1 million. SI unit is becquerel. If 1 nucleate decays per second, 1 decay per second, it is termed as 1 becquerel. If 1 million nucleate decay per second, 10 raised to the power 6, it is termed as Rutherford. And if this number is 3.7 times per 10 decays per second, it is termed as 1 Curie. 1 minute to write. Refer to the book, page number 8 by 86. Refer to numerical number 14, 1, 4. Numerical number 14 is half-life of a certain radioactive material is 100 days. After how much time the undecayed fraction of material will be 6.25%. Draw the diagram to explain what it is. If you draw the diagram, you can get the answer. Given is what? Half-life. How much? Yes? 100 days. What you need to find is you have to find out time. Yes? Time you have to find out. After which the undecayed means population remains how much? What percentage? When n is equal to 6.25% of original value. Number of questions in competition. Procedure is very simple. Original number is n naught, 100%. The number decreases exponentially. In one half life, the number reduces to half of original, 50%. Next one half life, yes, half of this value, 25%. One more half life, 12.5. One more half life, 6.25%. So, on graph you can solve it this way. We take how many half lives? Yes, 1, 2, 3, 4. So, graph method in this case is best. This is graph method. How many half lives? 1, 2, 3, 4. So time is equal to what? 4 half lives. 4 into, yes, one half life is how many days? 100 days. The answer is 400 days. This is one method. Second is your mathematical one. This is first method. This is second is your mathematical. Any number n, original number n naught. In one half life it is 2's power 1. In two half lives 2's power 2. In three half life 2's power 3. In n half lives it is 2's power n, where small n represents what? Number of a half life. Number, yes, what is the number here? 6.25. What is the original value? 100 divided by 2's power n. 2's power n is equal to what? 100 divided by 6.25. Yes, 100 divided by 6.25. Come out to the answer, please. Yes, 16. Correct? 100 divided by 6.25 is 16. 2's power n is equal to 16. Yes. 2's power n is equal to 16. 16 is what power? 2's power 1 is 2, 2's power 2 is 4, 2's power 3 is 8, 2's power 4 is 16. So n is equal to what? 4. So 4 half lives. Time is equal to what? 4 half lives. One half life is 100 days. It is 400 days. So for competition, this is very simple. In one half life graph, 50%, two half lives 25, 3, 12.5%, 4, 6.25 and 5, 3.125. Refer to numerical number 16. Numerical number 16. Numerical number 16 is the half life of radon is 3.8 days. After how many days 19 by 20 of the sample will decay? I've given you 16. Yes. Numeric number 16. Half-life is given. Half-life is how much? Yes. 3.8 days. After how many days 19 by 20 of the sample will decay? Say, after one half-life, yes, 50% die and the remaining population is 50%. After two half-lives, yes, what percentage is dead? 75 and 25 is live. Here question is 19 by 20 means what percentage? 95%. That means somewhere here. Remaining population is how much? 5%. This is where we want to reach. Approximate method and exact method. Approximate method. Method 1. You have to find out time during which population reduces to 5% of original. Try. One half-life 50%, two half-life 25%, three half-life 12.5, four half-lives 6.25 and further 1.25 change. Yes, this value reduces to what? 3.125 in how many half-lives? 5. 3, this value is how much? 3.125%. So by approximate method, this time will come out to be more than how many half-lives and less than? Yes. This value 5% lies between 6.25 and 3.125. This value will lie in between the two means what? 4 half-lives less than 5 half-lives. 4 into 3.8, 3.8 into 4 days and 3.8 into 5 days. Comes out to what? 15.2, 2, yes, 19 days in between the two. So in between the two you can have, if it is say approximately center of the two, we should not apply, it is not a straight line, it is exponential function. It is only for computation purpose or it is approximate method. If it is in between the two and if we assume it to be at the center, then it is 15, this is 19, 4, yes 15, this is 19, it is 4 units. Average of 15 and 19 comes out to be approximately 17. So time is approximately 17 days, but this method is approximate method. Now we will have exact method. Answer to this part is how many days? 16.43 days. This is approximate method. Anyone? Exact method. Method 2. Exact method. Exact method is it is time consuming, number 1. 2, you need to have log tables with you to answer this, which you don't have in competition. That is why it is only for boards. The number reduces to what? Yes, 5%. You have to find out time. Formula: n is equal to n naught e power minus lambda t. N is what? Number at any time. It is what percentage? 5%. So number is 5. What was the original number? 100. E is power minus lambda into t. It is 5 by 100. E is power minus lambda is equal to what? Yes, 0.693 by half-life. Half-life is 3.8 days. 0.693 divided by 3.8 days into t. E is power. It is e is power minus. You shift it to denominator. What you get is e is power 0.693 over 3.8 t is equal to what? 100 by 5 equal to what? 20. Now then, taking log on both sides, taking the values of log, lot of input is required. Then you come out with the time. And by solving this, if you solve this equation, only unknown is what? T, time. Then you will get exact answer, that is 16.43. Not recommended for competitions. It is always approximate method which will come out with the answer. Numerical number 22. Numerical number 22. 1 minute to go through. Numerical number 22 is the selling rate of a radioactive isotope is decided by its activity. What will the second hand rate of a 1 month, underline 1 month old P32 sample with half-life 14.3 days if it was originally purchased for 800 rupees? Half-life is given, how much? Yes, given half-life, how much? 14.3 days. Original activity R naught. Activity at any time, it will decrease exponentially with the time. And the price also depends on activity. Higher activity means high price. Original activity was R naught. What was the original price? Rupees 800. As the activity decreases exponentially, so price also decreases exponentially. We want to find out price after a time of, yes, 30 days. If T is equal to 30 days, first you need to find out activity reduces to what? So price will also reduce to the same fraction. If activity reduces to half, yes, suppose price will reduce to half, 400 rupees. If activity reduces to 1/4, price will also reduce to 1/4, that is 200 rupees. So question here is method 1, approximate method. Method 1, yes, original value, radioactivity 100%, 1 half life Yes, 50%. One half-life, 14.3 days. One more half-life. Yes, 14.3 days. This value is 25%. Solve it by approximate method. So you know the price in 28.6 days. Yes. This value, yes, 800. 50% means 400 rupees. 25% means 200 rupees. This is one half life, one more half life. So total time is 14.3 days, 14.3 days. Total time is 28.6 days. After 28.6 days, price reduces to, yes, one half 400, then again one half rupees 200. After 28.6 days, you know the price. But you want to know after how many days? 30 days. So you can come out with maybe 5, 10, 15 rupees less. It depends on what? Next half life, yes, the price will reduce from 200 to 100. In how many days? Yes, 14.3 days. Approximate analysis. In 14 days, next 14 days, price will reduce by 100 rupees. How many days? Yes, 28.6. You can say 2 days. In 2 days, it will be what? 100 by 7, approximately. Yes, 12, 13 rupees. Yes, 13. So, after 30 days, it is price is what? 200 minus 13, approximately 187. This is by approximate analysis. Exact answer is what? 182. Why there is error? Because the last part, during this part, you are taking some approximate analysis. Exact method. Yes, anyone? Exact method. Method 2, not recommended for competition. Not recommended. Exact method. N is equal to N naught, E is power minus lambda t. R is also equal to what? R naught, E is power minus lambda t. Price P is also original price, E is power minus lambda t. What is given to you is, yes, original value, yes, P naught, rupees 800. E is power minus lambda, 0.693. How many days? 14.3 days. T, yes, how many days? 30 days. So what you get is 800 rupees into E's power minus 0.693 into 30 divided by 14.3.